Okay, so who's ever heard of this guy, Sir Isaac Newton?
Never heard of him?
All right. Some of you made cookies. Yes. Well, that's a different Newton.
He was the guy who
That was So what's Isaac Newton known for?
Law of gravity.
Law of gravity. And beyond that, it's more than just the law of gravity. He developed, he codified or defined some of the basic laws of physics that have to do with motion. So that's exactly right. Have you heard about his first law?
Yeah.
Yes.
Okay, so it's on the sheet here. Yeah. You got to obey gravity. It's the law. You know, one thing about gravity is you'll find that as you get older, gravity gets a little stronger. You know, the scales keep saying we're getting heavier. It's just gravity is taking effect. So these are really kind of interesting laws. They affect everything around us. You know, I always found physics fascinating. I would encourage you, even if you don't want to go into that as a field of study, I would encourage you to make sure and take some physics classes along the way. It just opens up your horizons as to how the whole world works. So the first one is kind of interesting. It just says the natural state of things is if something is at rest and not moving at all, that's where it's going to stay unless there's some other force applied to it. Right? So kind of makes sense, right? So that's not complicated. What's complicated is what is a force and what are all the different forces that might cause things to move. That's where things get really interesting because some of those are sort of subtle. The second one is the one we're going to concentrate on today, though, which is kind of the opposite of that. And this was not quite as obvious. Anybody want to read the second law? This is just my paraphrase of the second law. Yeah, go ahead.
Object, body moving at a constant velocity in a straight line continues doing so indefinitely.
Right. So if you're moving forward, you're going to keep moving forward unless there's some force that changes that. And that doesn't really make sense because, like, if you're in a car or if you're on a sled, you don't keep moving, right? You slow down. Pardon me? Yeah. So there are forces. What Newton's saying is there are forces that alter that. If you're in a car and you're going 40 miles an hour and then you take your foot off the accelerator, you eventually slow down. What makes you slow down?
The air is pushing.
Pardon?
The air is pushing.
Air resistance is one force.
Friction.
Friction where?
Like on the tires.
The tires. If you go and feel your tire after you've driven for a while, it's hot, and that's because we've converted this kinetic motion into heat energy, right? So the tire's hot. So that's the energy is all there. It just moves into a different form. So why are we talking about that? Well, there's one instrument that really doesn't belong with the rest of the band instruments, and that's the trombone.
We've been trying to do that for years.
Yeah. So they let us come around with what is it that makes the trombone so much different from the other band instruments?
It doesn't have a button.
It doesn't have any buttons, and in fact, you have to move this to change your pitch. Right? You have to move your slide. What would Newton have to say about your slide movement?
That it's all about the force.
Like,
Yeah, he said that's a funky instrument. No, I don't think that's what he would say. I think he would say, "Wow, this thing has mass, and in order to move it, I must. That's what we call acceleration. I accelerate it, and I accelerate it the other direction. If you turn over your page, that he actually has a formula for that. What's the formula say?
mass times acceleration equals force.
Force equals mass times acceleration. So what that says basically is if you're pushing on something with a small amount of mass, you need less force to accelerate at the same amount. Acceleration is when I move from one position to another. So the more massive this slide is, the more force I have to use. Right? So that's not necessarily a good thing because you would rather not have to use a lot of force when you're playing your instrument, whether it's playing a piano or playing any of your instruments. You don't really want to have to force the instrument. So if you were Isaac Newton and you said, how am I going to build a more playable trombone? I guess you got a couple choices. You could go work out, right, so that you have more power, so that you can apply more force.
You could make it smaller.
You could make it smaller. You could make an alto trombone or soprano trombone. What would that do?
Well, I'd also change it.
Decrease.
it would decrease the mass. And if the mass is half the size, if the trombone's half the size, then the amount of force would be half the amount of
Problem
force.
solved.
Except that it's an octave too high now. Yeah. So if you want to keep it in the same octave, what could you do? You could reduce the mass of the slide. How would you go about doing that? You know, we could probably take off the water key. We could take off that little bumper on the end.
Make it out of something lighter.
Make it out of
Or make
something
it
lighter.
thinner.
Make it out of something lighter. So yeah, so that's exactly what you could do. So this is a standard trombone slide.
You could wrap it in bubble wrap.
You could wrap it in bubble wrap with bubble wrap filled with helium.
Attach a balloon to
All right, so this is all right. Since you had the idea, come up here.
It's got a piece of tape on the side.
Oh, okay. We'll get that. All right, this is. All right, I want you to hold this in one hand. Hold this in your other hand. Which one's heavier? Yeah, by quite a bit. It's about 3 times as heavy. All right. So what do you think this is?
Is
Yeah.
it metal?
It's a carbon fiber.
This is a carbon fiber slide, so I'm going to take this one away.
Mr. Cleveland, you can't answer these questions.
I was purely against.
Yeah. This was
Okay.
okay. That's. I'm going to have you back up in a minute, but you can take your seat here.
Too,
So this is this slide was made by a guy named Jimmy Dell, and that maybe we don't have time to go into his background.
A very weak
guy
guy
but-
named Jimmy.
Yeah, his actual name was Jimmy. He's still alive. His name is Jimmy Dell Guicio or something like that. You won't know this name probably, but there was a really famous entertainer called Louis Prima, and from a little bit at the end of the swing era into the 60s and 70s.
He has the Angelina song.
Yeah, he had a lot of stuff. You know, it was real wild stuff. Well, Jimmy Dell was in Las Vegas and wanted to be he was an aspiring musician, but he actually got a job as Louis' chauffeur, and eventually got himself in. He's a trumpet player, and eventually got himself into the band because he was a chauffeur. So as long as you're paying the chauffeur's salary, you might as well let the guy play trumpet. Right. Well, but I actually talked to Jimmy's son. Jimmy's about 90 now, and he still plays. But I talked to his son last year, and it just seemed like he was a real interesting guy. So he made these because he also played a little trombone, and he thought, well, why not do that? The problem with this is a first generation. This was made about in the 1970s, and it doesn't have a bad sound, but it's kind of a soft material, and it deadens the sound. So while it's super fast compared to a regular slide, it doesn't play as well, and so it's not as loud, and it loses its overtones, so it doesn't have as much of a characteristic trombone sound. But it was still a blast to play. I just didn't play it very, very much because of the other problems. If you're playing, for example, if you're playing in a big band where you've got to project, it's probably not going to happen for you. So we fast forward now a few years. There's a company in Switzerland, because the technology has moved along. And this company is called Sperling. And so come back up here if you would. This is another carbon fiber slide. I just had this made about 6 months ago. So why don't you pick that one up. Okay, now see if you can tell the difference on these. Yeah, it's actually not, but it feels lighter. I mean, it's kind of it's a paradox. We talked about the word paradox in our sectional, and this is another paradox.
That's when both of your parents are dying.
Yeah, that's right. Yeah, so it actually feels lighter, but it's actually a little bit heavier. But the key thing is, can you tell anything about the hardness of the material or how it looks? Can you tell anything about that?
Different patterns.
Different patterns for sure.
And different harder.
It is harder, and okay, that's what we need. Thank you. And so this is actually using a product. This tubing, the straight tubing, is actually manufactured for undersea pipes, undersea tubes. So it's very, very hard.
Finally, you can play trombone underwater.
That's right. That's right. So it's a commercial product made for that reason, but they've been able to get it spec'd in the right dimensions to make trombone slides out of it, and they've actually been able to change the weave here to do different things with the acoustics. So this one actually plays really well.
Is this still carbon fiber?
This is still carbon fiber. It's a real modern, the latest carbon fiber, and there's basically no penalty as far as I can tell. It sounds good. It sounds like a trombone. You don't really change the timbre very much at all by playing it. If anything, it actually maybe enhances overtones, which is normally a pretty good thing for an instrument. The only thing that I found with I've got two of these slides, one for a different instrument, and if I say slotting, does that mean anything to you brass players? Slotting. Slotting. Do you have any idea what I mean by that? So when a brass player plays, you can have the same note. It's like a bugle sequence. You can have all sorts of harmonics. You get a few on woodwinds, but not as many as the brass. So. So those are all available in any particular position. All right, so each one of those we call a slot. And so with this slide, it's actually a little more precise. So if you have your slide a little bit in the wrong position, you're more likely to chip a note or to make a bad attack on this slide than with a brass slide. So it requires a little more precision. So why would this be a good thing as far as if we go back to Newton's laws?
Because you can push the head of your ball without breaking the slide.
Yeah, you can play faster. From my standpoint, it's not just playing faster. It's playing with having to use less effort, and so you can play in a more relaxed manner. And you can it's easier to put some of the nuances. A lot of things that we do with trombone, particularly in a jazz idiom, is we do a lot of nuances with the slide. And so being able to not have to think, it's basically like air guitar. You don't really have to think about what you're doing with the slide because it's so light. It allows you to do a little more styling without really thinking about it. So I'm going to give a little demonstration here and see how this works.
Thank you.